Greetings, Algebra 2 students, and welcome to week 3 of e-learning. This week, we are going to talk about the idea of inverse functions. Before we start, let's do some warm-up and some prerequisite review. You have been doing inverses since middle school. Why? Well, if I give you the number 4, if I asked you, with respect to addition, how do you undo 4? Well, if you have a 4, you would subtract 4 because if I took 4 plus a negative 4, that gives me 0. This is what we mean by additive inverse. Another word for inverse is to undo. So if I asked you, how do you undo adding a 5/7, you would undo it by subtracting a 5/7. If I was asking you, how do you undo a -9, you would undo it by adding 9. If I asked you, how would you undo subtracting 8/3, you would do it by adding 8/3. If I asked you, how do you undo adding a 1, you would undo it by subtracting a 1. And last but not least, if I asked you, if you're subtracting 1, how do you undo it? You would add 1 because of each of those cases. If you took the add and the subtract, they undo and they cancel to give you 0. So that was everything about an additive inverse. Let's talk about what it means to be a multiplicative inverse. All right, so if I was asking you, like if you had 4x equals something, wouldn't you undo it by dividing by 4? Dividing by 4 is the same as multiplying by 1/4. So if I take 4 times 1/4, this gives me 4/4, which is 1, and that's the multiplicative identity. So if you're like, okay, great, Nat, thanks for that, but how am I going to answer my homework? The multiplicative inverse is just the reciprocal. So this is 4/1. Its reciprocal is 1/4. That's the multiplicative inverse. Why? Again, because 4 times 1/4 gives me 4/4, which gives me 1, and that is how they cancel. So how do you undo multiplying by 5/7? You divide by 5/7, which is the same thing as multiplying by its reciprocal. So 7/5 is the multiplicative inverse of 5/7. So what is the multiplicative inverse of -9? Well, it's -9/1, so -1/9 is its multiplicative inverse. Again, if you're wondering why, because -9 times -1/9 gives me -9/9, which is 1. So in other words, they cancel. What is the multiplicative inverse of -3/8? We just take its reciprocal. We continue the sign. We do not change it to a positive. This is 1/1, so its reciprocal is 1/1 or just 1. And -1/1, its reciprocal is still -1/1, which is -1. Reminder, if this went too fast, you can pause, stop, rewind at any time. But your first homework problems will just be to tell me what is the additive inverse. So how do you undo that number by adding or subtracting? And then what I have written in red, you give me the reciprocal, because the multiplicative inverse, the number, all right, the number times your multiplicative inverse has to equal 1. Next, let's talk about the inverse of a relation. Pardon me. The inverse of a relation is found by exchanging the x and the y coordinates of all points graphed. So if I was referring to the point -4/5, -5/4 would be its inverse coordinate. If I was referring to the point 3/2, its inverse coordinate is just switching the x and the y. If I would be referring to the point 0.5, its inverse coordinate would be 5, 0. You just exchange the x and the y coordinates. So how is that going to look like on homework problems? Well, This point right here that I have in red is the point 1, negative 2. So its inverse point would be negative 2, 1. Next, if I look at this point that I've highlighted in purple, that coordinate is 2, 1. Its inverse point would be 1, 2. And last but not least, if I look at the point I've highlighted in blue, that is the point 3, 4. I wrote it in the wrong spot. Hold on. So its inverse point would be 4, 3. Let's do some examples. At this point, this might be, if you understand what you're doing, then go ahead and stop, do the problems, and then fast forward to see if they're correct. So what I'm going to do next is I'm going to go ahead and write the coordinates for each of these points. So that's negative 3, 4. This is negative 2, 2. This is negative 1, 0. This is negative 2, 0. Wrong, 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 wrong. My apologies. This is 0, negative 2. And this is the point 1, negative 4. When I want to write their inverse, all I do is flip the points. You don't flip the signs. You keep the signs the same. You just exchange the 0 and the negative 1, the negative 2 and the 0, the negative 4 and the 0, and let's graph. And I have another misprint. Sorry. Oops. This should be the point negative 4, 1. Okay. Let's do it again. In red, I'm going to put all of the original points. So those are the points negative 5, negative 4, 0, negative 3, 5, negative 2. And then when I figure out their inverse, I switch the points. And let's graph. Okay, let's do the next problem. Pardon me. Again, in red, I'm going to go ahead and just write those points. And then when I need to figure out the inverse, I flip the points. And then we graph. So here's what I want you to notice graphically. It's a pattern. You can absolutely do the homework without understanding the next question. But the next question is asking you, what do you notice about each relation and its inverse? And I think it's easiest to look at this graph first. What you hopefully will notice is that there is a mirror in the graph. If you look, this is the line y equals x. It has the points 1, 1, 2, 2, 3, 3, 4, 4 on them. This is called the identity function. Again, y equals x. Well, notice how you have this point right here and this point right here. Do you see how they're mirrored over those lines? This point is a mirror over those lines. This point right here is a mirror over those lines. If I look here, these are mirrored points, these are mirrored points, these are mirrored points. And if I look at the first question, all right, then these are the mirrored points, these are, and those. You have mirrored points. So again, I want to let you know that this is the y, and this is not, like, if you're like, okay, that's not making sense, it's okay, you're going to be able to do the homework. But it is important that graphically, what you should notice about each relation and its inverse, they reflect over the line y equals x. So that is the big theory. So the following, this set right here, of inverse functions has some really good information. First of all, when we say the word inverse function, that's how I say it out loud. This is the English word, but this is the math symbol. That -1, you don't compute it. This is just how we denote an inverse. All right, I have crossed this part out. That's part of the lesson I am cutting during the e-learning. But this will be important. In what we just did, didn't we exchange the x and the y variables to find an inverse? And that's what our homework is going to look like. This you can cross out. That is part of the lesson I'm cutting out. And this is an important note. The symbol -1 is not an exponent. So just to be clear, we do not do anything with calculation with that. It's just a way of naming the inverse. So here's what we're going to do for the remaining problems. You're going to find an inverse function. So we have talked about in this first part. In this part, we talked about these as inverse operations. That's what this first box was about. Inverse operations. How we add and subtract to undo. How we multiply and divide to undo. Then we talked about inverses as a set of points. We exchange the x and the y. Now we're going to talk about how we find the inverse of a function. And I have step 1, step 2, step 3, step 4. So let's say that your problem was f of x equals 3x squared. Step 1, we change the f of x to a y. Step 2, you do what we did in the previous problems. You switch the x and the y. So every x becomes a y and every y becomes an x. Then here's the math part. You solve the equation for y, and friends, look on the left, read. Solve the equation for y, which means we have to get this y by itself. And then in step 4, we're going to replace the y with our symbol inverse of f to denote it's our inverse. I'm going to go through the next examples fairly fast so that we keep the length of the video down. So make sure that you stop, pause, and rewind at any point. Here we go. All right, problem number 1. Step 1. On step 1, we don't have to do step 1 because there's no f of x in the problem. Step 2. We replace every x with a y and y with an x. So this becomes 3y plus 2x equals 4. Step 3, we have to get this y by itself. How do I do that? I'm going to subtract 2x from both sides. Then I'm going to divide everything through by 3. So -2/3 does not reduce. 4/3 does not reduce. And then for step 4, notice how it's confusing. There's a y up here and a y up here. But friends, this is my inverse function. If you would graph this function and this function, they would reflect over the line y equals x. So in step 4, to denote that this is my inverse, I say f inverse of x is equal to -2/3 x plus 4/3. Let's do another example. Step 1. Step 1, we don't have to do. There is no f of x in the problem. Step 2. We replace the x with the y, and we replace the y with an x. Step 3. I get the y by itself, so I add 6x to both sides. So 8y is equal to 6x plus 24. Then I divide everything through by 8. So y is equal to 6 over 8 reduces to 3/4, and 24 over 8 reduces to 3. Feel free to use a calculator. And For my final answer, I change this y because this is my inverse function. I denote it using math symbols by f to the negative 1 of x is equal to 3/4 x plus 3. All right. In this problem, I am going to go ahead and distribute. I think it makes the problem easier. All right, step 1. Step 1 we don't have to do because there is no f of x in the problem. Step 2, I replace the x and the y. So I have x is equal to negative 6y plus 12. Step 3, I have to get y by itself. So I'm going to subtract 12 from both sides. And next, I'm going to divide by negative 6. All right, I can rewrite that as negative 1/6 x, and then negative 12 over negative 6 is a positive 2. If you are struggling at all with how I'm getting that, please input and use a calculator. So for my final answer, since this is my inverse function, I'm not going to use y, but I'm going to write it as the inverse of x is equal to negative 1/6 x plus 2. Sometimes kids ask me, Mrs. Knopp, do I have to write it that way? Could I have done this? And the answer is yes. Some kids write this as x minus 12 equals negative 6y, and then they just rewrite their inverse as x minus 12 over negative 6. These are equal. Both of these are correct. It is your personal preference how you want to write it. Okay. Here we go. I'm going to rewrite this by distributing and make this f of x is equal to 4x plus 36. Okay, here we go. We do have to do step 1. Step 1, because we do have an f of x, I'm going to rewrite this as y equals 4x plus 36. Step 2, replace the x's and y, switch them. So x is equal to 4y plus 36. Step 3, I have to get y by itself. So I'm going to subtract 36 from both sides. Then I'm going to divide everything through by 4. Again, it is okay to leave it as x minus 36 over 4. I'm just trying to prepare you for the future. So this becomes 1/4 x. 36 over 4 is 9. And since this is the inverse function, I'm going to write my final answer as the inverse of x is equal to 1/4 x minus 9. Don't let the fact that there's a fraction in here give you the heebie-jeebies. All right, here we go. Step 1. Step 1 is unneeded because there is no f of x in the problem. Step 2. I'm going to replace the x and the y. Step 3. I need to get y by itself, so I'm going to add 1 to both sides. And I want you to write this as 4y over 5. Why? Because in order to get the y by itself, I have to multiply everything through by 5. So the trickiness to this is you have to distribute. Everything has to get multiplied by 5. Then I'm going to divide everything through by 4. 5/4 does not reduce. So I get that my final inverse function is equal to 5/4 x plus 5/4. All right, 3 more to do, friends. On these problems, these are quadratics, so there is something a little bit special that happens. But notice that we are still doing the process. Step 1, change f of x to y. Step 2, replace the x with the y and the y with the x. Step 3, we're going to solve for y. That means we need to get this y by itself. So I'm going to subtract 19 from both sides. And this is where something different comes up. in order to get rid of the power of 2, and this is why this is in the radicals and roots unit, I need to take the square root of both sides, but you don't just get the root x minus 19, you get a plus or minus. So my final answer, the inverse, so this is my inverse functions, would be the inverse of x is equal to plus or minus the square root of x minus 19. Okay, let's do it again. Step 1. We're going to replace f of x with y. Step 2. I'm going to exchange the x and the y. Step 3. I'm going to solve for y by adding 26 to both sides. X and 26 are not like terms. And then we're going to square root both sides, giving me a plus or minus. So I'm going to write my final answer as the inverse of x is equal to plus or minus the square root of x plus 26. And friends, now we are at our final problem, star it. It's really not hard, but there is like a place where you just have to be mindful of what you're doing. All right, step 1 is unneeded because there is no f of x. Step 2, I'm going to replace the x and the y, but this is why it is starred. Your y is trapped inside the parentheses, which means you're going to have to get rid of that power of 2 first. So to do that, I'm going to take a square root. It's only the x that is underneath the square root, and it gets the plus or minus. Now the square and the square root cancel, giving me a y plus 3. So when I get the y by itself, I'm going to subtract 3 from both sides. But to be clear, that minus 3 is not under the radical. So my final answer is that the inverse of x is equal to plus or minus root x only with a minus 3 on the outside. So at this point, you are ready to do the assignment in the assignment post. As a reminder, if you have questions, I am on Zoom 10:30. You can get the link from Google Classroom, and good luck.